It's one of the largest underground military command centers in the world, responsible for protecting the skies over North America, capable of monitoring enemy missiles around the globe, and in charge of deterring terrorists in the aftermath of 9/11. And it's buried deep inside a mountain. This is NORAD, the North American Aerospace Defense Command Center. Its state-of-the-art computer systems are linked to a worldwide early warning network of satellites, sensors, and radar. NORAD's mission is to track all top-secret intelligence transmitted from this sophisticated warning system. But its top priority is to use that intelligence to monitor the skies for incoming strikes against North America, to assess potential threats, and coordinate a military response, giving U.S. forces enough time to intercept or shoot down the enemy. Manning this megastructure are about 1,500 military and civilian employees from the U.S. and Canadian armed forces. Their motto is deter, detect, and defend. The idea for a command center of this caliber first emerged during the tense nuclear arms race between the United States and the Soviet Union. The need for NORAD became critically clear on the 29th of August 1949, when the Soviet Union detonated its first atomic bomb at a test site in Kazakhstan. America's position as the world's leading superpower was now in jeopardy. To counter the possibility of a nuclear threat from the Soviets, the United States and Canada combined their resources to form the North American Aerospace Defense Command, or NORAD. By 1958, NORAD's detection system relied on a global network of 57 radar sites planted above the Arctic Circle. This was called the Distance Early Warning Line, or DEW line. But NORAD's nuclear defense had an Achilles heel: the headquarters itself. NORAD was operating out of an old hospital in downtown Colorado Springs. And although it was close to other military facilities, including a U.S. Air Force base, the building, built in 1923, was a vulnerable target.
The commander at the time said, "There's a problem here. Anybody driving by with a bazooka could knock out this command center."
Military officials were forced to rethink the location of NORAD's headquarters. They needed a protected site and a structure that would be virtually indestructible. The Army Corps of Engineers was brought in to design a state-of-the-art military fortress.
We needed something that would be able to survive a nuclear attack so that we could respond in kind, and the Soviets would know that, and therefore, hopefully, not attack us in the first place.
The Army Corps of Engineers had been the mastermind behind the Pentagon military complex 17 years earlier, and America's top-secret missile silos in the 1950s. But the concept for this mountain complex came at a time when engineering technology was relatively unsophisticated and limited. In 1958, computers, as we know them today, had yet to be invented.
The engineers used slide rules when they built this facility.
The military designers proposed 3 potential locations for the megastructure. They could dig out a concrete underground bunker, like those constructed during World War II. They could erect NORAD inside an abandoned mine. Or they could implement their most extreme design by carving out the inside of a mountain. 2,000 feet of natural solid granite protection convinced the engineers to build NORAD deep within a mountain. The next step was to find that mountain. They began the search in their own backyard, the Colorado Rockies. And soon engineers had narrowed the choice to 2 sites: the 9,423-foot-high Blodgett Peak and the 9,565-foot Cheyenne Mountain. To ensure they selected the best option, engineers analyzed rock core samples from each mountain, a process that could determine which one would offer the sturdiest protection for this unique underground megastructure. Helicopter pilots were hired to transport men, generators, and heavy core sampling equipment to the sites. At each location, survey crews drilled holes 3 inches in diameter and up to 1,600 feet deep. Then, using a borehole camera, they photographed the rock structure inside the 2 mountains.
When they did the core samples in Blodgett Peak, they discovered that there was a lot of water compared to Cheyenne Mountain. They had much harder rock and much more consistent rock in Cheyenne Mountain.
Because it had a more stable rock structure, Cheyenne Mountain was selected as the future home of NORAD. Engineers now had to map out the construction project. Phase 1 was excavating tunnels, chambers, and reservoirs inside the mountain to create a 5-acre military installation, big enough to hold 5 football fields. Phase 2 was to build a self-supporting city with 12 interlocking personnel buildings and its own water reservoirs, fuel supply, power plant, and ventilation systems. Like the Pentagon, this city would be open 24 hours a day. Staff would be stationed at roughly 800 desks and operate about 1,000 computers. NORAD would also contain amenities like a gym, corner store, and cafeteria. Many of the building's exact details remained under wraps due to the high security protecting this top-secret facility. But there was one characteristic that set this headquarters apart from other megastructures: the ability to completely seal itself off in the event of a nuclear attack. NORAD would have to be able to function and keep its personnel alive for 30 days without any support from the outside world. For Phase 3 of the NORAD military complex, technical engineers would install a powerful scientific computer linked to a super surveillance system capable of monitoring missile activity around the globe. NORAD was considered a Level 1 facility, meaning this structure would have the highest operational security available. Building this military headquarters presented a challenge unlike any that engineers of the time had previously faced. 700,000 tons of granite had to be excavated from inside the mountain, a weight equal to almost 4,000 commercial jets, before construction of the buildings could even begin. By late September 1959, 2 years after the initial conception of NORAD, construction crews hit their first obstacle. Engineers had positioned the North Tunnel entrance 1,000 feet above the base of the mountain. But the site was so remote that men and machinery couldn't access it by land. A 4-mile-long road had to be planned and bulldozed before crews could start excavating the mountain. It took more than 2 months to complete the road, from its beginning in Colorado Springs to the end point 1,000 feet up Cheyenne Mountain. But by November 1959, just as the new road was almost ready to transport crews and equipment, the entire project came to a screeching halt. The roadblock this time was money. Congress didn't approve additional funds for NORAD. At the beginning of 1960, with the threat of nuclear war still a frightening reality, it looked as if America's answer would never be built. In November 1959, all across the United States, Americans were living under a nuclear threat. The US government was building what it believed was America's only viable solution: a top-secret military complex capable of seeing into every corner of the world. But construction crews had only just finished the $1 million access road when the government shut down the entire project. Estimates to complete the project ran at more than $26 million. Military officials were constantly updating and resubmitting NORAD's initial plans. It was another 16 months before Congress finally approved the design and funding of this underground megastructure, and construction could begin again. Once the green light was given, military officials staged a highly public groundbreaking ceremony for their top-secret fortress. This was a message to the Soviets that the United States was taking the threat of nuclear war very seriously.
There was no secret. What was secret at the time, and remained secret really up until the 1980s, was exactly how hardened that facility would be. What kind of a nuclear blast could it survive?
On the 16th of June 1961, top military officials detonated the first blast. 3 interrupted years after NORAD's preliminary design had been drafted, construction finally began. It started with a mammoth dig. A crew of just 90 workers had 1 year to carve out 5 acres and remove 700,000 tons of granite to form 2 main tunnels and 7 60-foot-tall caverns, the equivalent of 5.5 stories. These holdout chambers would become the protective shell for NORAD's 12 interlocking staff buildings and 3 industrial structures, including a power plant. The total size would be 104,980 square feet. The 2 tunnels would lead to these buildings from opposite sides of the mountain. The first job for the excavation crew was to blast out the tunnels. From day one, engineers faced one of their biggest hurdles: how to keep thousands of tons of rock and debris from burying the whole project. Blasting was the fastest and cheapest way to excavate the granite. Miners at NORAD attempted traditional blasting techniques, with dynamite heavily packed into drilled holes. But they soon realized that this method risked fracturing and loosening the rock. In the worst-case scenario, it might cause the cavern ceiling to come crashing down on top of them. Crews needed to develop a more controlled way of blasting that would keep the walls intact. Dr. Paul Woersey is a blasting expert who consulted on the NORAD megastructure. Woersey shows how the traditional blasting method can cause a rock wall to crumble and cave in.
All these fractures here are blast-induced, and it's really loosened up. I can even pull the material off with my hands quite easily. Now, if I could do that with a steel bar, just imagine what the shockwave from a nuclear weapon could do.
To avoid a cave-in, NORAD's explosives team used a new technique developed in 1956 called smooth wall blasting. In this technique, miners first calculate a blasting pattern by painting a series of arched lines on the granite walls. Holes are then carefully drilled along those lines and loosely packed with large sticks of dynamite. Timing is crucial. Each arch must be detonated from the inside out in a precisely choreographed sequence. On the outer arches, the rock shears off cleanly, leaving behind a smooth wall. Dr. Woersey demonstrates NORAD's smooth wall blasting technique. With everyone at a safe distance from the site, the countdown begins.
Fire in the hole! 3, 2, 1!
There's no collapse.
A nice, fairly smooth wall. There's hardly any cracking on holes at all.
Fewer cracks means a more stable wall, which was exactly what NORAD's blasters and engineers finally achieved at Cheyenne Mountain in the autumn of 1961.
If they had not used these very innovative, carefully planned mining techniques, blasting techniques, the chances of having a facility that would survive a nuclear blast would have been minimal.
The excavation crews still had to meet their deadline of June 1962. So blasters worked in 3 shifts around the clock, 6 days a week, attacking the mountain from both ends. The design plan called for the 2 tunnel crews to meet at a central juncture point. There they would excavate the main cavity for NORAD's 15 buildings. On the south side of the mountain, one team bored the access tunnel for NORAD's ventilation system. It was 2,668 feet long and 17.5 feet high. On the north side, another team blasted out the megastructure's main entrance. This was a shorter tunnel, 1,416 feet long and 22.5 feet high. Blasting, digging, and carving out tunnels thousands of feet long through a mountain took time. No one knew for certain if the command post would be completed before there was a Soviet attack. On the 13th of August, 1961, the Soviets started to build the Berlin Wall. And 3 weeks later, they began to test a whole new generation of nuclear bombs. The workers at NORAD were now in a race to deter a hostile superpower. Just 3 months after their start date, the workers reached a milestone. On the 7th of October 1961, crews from the north and south tunnels met. Together, they'd carved through 4,675 feet of solid granite. It was a monumental achievement. But the tunnels were just the prelude to the main event. Digging out NORAD's 7 central chambers would be an even tougher job. And the crew had just 8 more months to finish the entire excavation. It was a daunting task. And in the heart of the mountain, where the chambers would be hollowed out, engineers were about to hit another major obstacle, one that would threaten to derail the entire multi-million-dollar project. On the 30th of October 1961, the Soviets tested the most powerful atomic weapon ever built. It was the 57-megaton Tsar bomber. Nearly 4,000 times more powerful than the bomb dropped on Hiroshima 16 years earlier. The blast had repercussions halfway around the world, at Colorado's Cheyenne Mountain, where engineers were constructing a command post that had to be able to withstand a nuclear blast. Working around the clock, construction crews had carved out more than 6 million cubic feet of rock for NORAD's 7 central chambers. But 3 months into the dig, engineers uncovered a dangerous weakness in the mountain's geological structure. What they discovered were huge fractures above the 3 main chambers, meaning that even the vibrations of a small earthquake could potentially cause the entire cavern to collapse. Engineers needed to address this new risk or terminate the entire project. They went back to the original blueprints and came up with a radical proposition. They decided to rotate the chambers 70 degrees and reposition the entire excavation project. In this new design, the cracks over the future buildings became shorter, minimizing the effects of an earthquake or nuclear blast.
If they had not changed from the original plan for that portion of the excavation, it's likely that A, you would have had problems with caving rock, or B, if there had been a nuclear attack, the vibrations to the entire mountain would cause that to collapse.
With the revamped design complete, construction crews were now ready to carve out the 5 reservoirs. 4 of the reservoirs would hold a total of 6 million gallons of water, enough to fill more than 20 Olympic-sized swimming pools. The fifth reservoir would hold 500,000 gallons of diesel fuel. The surplus would run the 6 generators that provided NORAD's power. With the reservoirs complete, construction crews were just a few months away from their June 1962 deadline for excavation. But soon the mountain's natural elements presented another challenge for NORAD's blasters. Engineers discovered that large sections of the mountain were filled with water. So much, in fact, that the miners couldn't possibly pump it all out. Too much water is a nightmare for blasters, creating fractures in the rock. And miners have no control over the way fractured rock explodes. The miners were forced to find another type of explosive. They tried out a compound called slurry, made from ammonium nitrate. Slurry can be molded to fit any crevice, so it can fill a hole that's cracked. But blasting away tons of rock would weaken the mountain's structure. So engineers decided to secure NORAD's unstable granite roof with giant steel rods called rock bolts. Measuring between 6 and 32 feet in length, these metal dowels would provide critical structural support.
Rock bolts are really important in tunneling because they're a method of stabilizing the roof. We actually pin loose pieces of roof to stabilize them.
Workers installed the steel rods into the walls and ceilings of the chambers. The tip of each bolt had an 8-inch split that held a steel wedge. Compression drove the wedge into the steel rod, spreading its tip and anchoring the bolt against the surrounding rock. Crews inserted bolts 4 feet apart throughout the chambers and tunnels. Each bolt was then tightened against a steel plate on the surface of the rock. But as the miners continued to carve out more chambers, they discovered that another natural element was also weakening the rock cavern around them. Volcanic rock called basalt. Softer than granite, basalt deteriorates and falls apart when exposed to air. So the miners decided to spray the rock with a concrete mixture called gunite. This hardens into a solid wall and would therefore prevent the granite from deteriorating. With all these unexpected complications, the construction crew struggled to stay on schedule.
People were working 6 days a week, basically around the clock, and they knew that national defense, possibly national survival, depended on doing this job quickly and doing it right.
Finally, on the 18th of June 1962, just 2 days after their deadline, workers finished the dig. Phase 1, excavating the mountain, was complete. Almost 1 billion pounds of rock had been removed from Cheyenne Mountain, enough to fill 23,000 dump trucks. Engineers were now ready to start Phase 2 of the monolithic megastructure, constructing NORAD's 12 personnel buildings and 3 industrial structures. 6 generators and a complex ventilation system would also have to be installed inside Cheyenne Mountain. But what the engineers didn't know was that their plans were about to be turned upside down by the unexpected fallout from a dangerous new weapon. By July 1962, construction crews working 2,000 feet inside Colorado's Cheyenne Mountain had carved out more than 5 acres of granite to make way for one of the most important megastructures in military history. Engineers had already completed the designs for 15 buildings that could withstand a nuclear blast. The NORAD Mountain Fortress would be America's first line of defense against enemy threats. But new advances in weapons technology were threatening to neutralize the whole project. On the 9th of July 1962, more than 200 miles above the Pacific Ocean, the US detonated a high-altitude bomb in a nuclear weapons test. An unexpected byproduct of this explosion was a newly discovered phenomenon called an electromagnetic pulse, or EMP. An EMP generated 200 miles above Kansas could cripple the entire United States by preventing electronic devices from functioning. And NORAD depended upon electronics operating around the clock to successfully accomplish its mission of surveillance. Back at Cheyenne Mountain, engineers realized that even thousands of feet of granite would offer no protection at all against an electromagnetic pulse. The one substance that could ward off the destructive pulse was metal. Like a lightning rod, metal directs electromagnetic pulses to the ground. But shielding all of NORAD's wires and computers in metal was impossible. If there was even a single gap in the shield, the pulse could short out the entire complex. Just as engineers prepared to erect NORAD's buildings in February 1963, they came up with a solution. They would construct the buildings themselves entirely out of metal to ground the path of the pulse. Thick steel walls were brought inside the structure in sections, the only way to fit them through the tunnel opening. Once inside, they were welded together at the seams. These steel walls would protect NORAD's sensitive electronic systems by transferring an incoming electromagnetic pulse through the metal to the ground, where it would be absorbed and neutralized. Actual construction on NORAD's steel buildings began in March 1963. But 7 months later, the engineers hit another wall. They determined that a geological fault in the roof of the main chamber would not withstand a nuclear detonation. They thought this problem had been solved when they'd pivoted the planned structure almost 2 years earlier during the excavation phase. But they were wrong.
Even though they reoriented the complex, there was still a crack over a part of that complex, and that caused a great deal of concern.
Under this crack was the proposed site of NORAD's most important building, the command center, home to crucial monitoring and surveillance systems. So engineers came up with a new plan. They would install a giant concrete shell, 50 feet in diameter, just inches below the main chamber's granite ceiling. Its purpose would be to prevent NORAD's future 3-story command center from being buried under tons of crumbling rock. The enormous dome, ranging from 4 to 14 feet thick, was made from steel-reinforced concrete. It would be supported by 4 massive 3-story high concrete columns. It was so large that it had to be fabricated outside the mountain and transported through NORAD's tunnel entrance in pieces. Workers used hydraulic jacks to reassemble it inside the mountain, lifting it into place on top of the columns. To stabilize it further, the dome was fused to the cavern's ceiling. 6 months later, the dome was assembled and in place. The construction of NORAD's main buildings was now the top priority. But there was still one other menacing phenomenon to tackle. In a nuclear blast, the mountain would transmit shock waves directly to the buildings, injuring people and damaging sensitive computers. To combat these waves, engineers came up with their own version of shock absorbers. Giant springs 3 feet tall, nearly 2 feet wide, weighing half a ton each. 1,319 springs would protect NORAD's buildings from shockwaves. This was a first in engineering history. No other structure had ever employed such an innovative shock absorption technique. Step by step, work on the rough steel structure of NORAD's interior buildings continued. When complete, the buildings were all interconnected to form a basic grid pattern. It was inside this building, the Command Operations Center, that technicians eventually installed the brains of NORAD, its global surveillance system. In adjoining buildings, workers constructed other features of the megastructure, including a medical clinic and a shop. In April 1964, workers were 14 months into building NORAD's self-supporting city. The 15 buildings were complete, and crews now began work on the support systems. First, they built the power plant that would run the entire command post. At its heart were 6 turbocharged diesel engines, the same kind used to power battleships. Together, they could generate 10 megawatts of electricity, enough to power more than 1,000 households. Next, crews loaded fuel and water into the 5 reservoirs they'd already carved out. One reservoir held 1.5 million gallons of water for drinking and cooking. In the 3.5 years since NORAD's first official blast of dynamite, workers had overcome all kinds of obstacles. But the NORAD facility was still vulnerable to one lethal menace. Radiation from nuclear fallout. By early 1965, the first 2 phases of the NORAD command center were near completion. The tunnels, interlocking buildings, 4 water reservoirs, fuel supply reservoir, power plant, and ventilation system had all been constructed. But before the 3rd and final phase could begin, installing the technical equipment that would be the brains of this military megastructure, one last detail had to be addressed. In the event of a nuclear explosion, damaging shock waves and thermal radiation would be able to enter NORAD through 3 routes: the air intake delay ducts and the 2 tunnels. The tunnels were designed as blowaway areas. Shock waves would travel in one way and out the other. But the air ducts led directly into the NORAD complex. If a thermonuclear shockwave got through these ducts, it could destroy the buildings. The solution was to create a safeguard called a blast valve. NORAD has 58 of them, weighing 8,500 pounds each. Inside this 4-foot wide tube is a movable seal that opens and closes the valve. In the event of a nuclear blast, this creates a change of air pressure. In less than half a second, NORAD's blast valves automatically seal the air intake ducts leading directly to the facility. The contaminated air is then forced to go through a filtration system called a CVR filter.
The fresh air that comes in is forced through those filters where we ensure that no radiation, no chemical agents or biological agents could get through into the complex.
But there was one more weakness at NORAD that engineers needed to address: the entrance doors into the complex. Located along the tunnels, they had to be able to seal off the facility during a nuclear blast. For this, engineers borrowed from a different design. The inspiration for their solution was a typical bank vault door. Engineers created a mega version they called a blast door. It's 3.5 feet thick and weighs 50,000 pounds. Hydraulic motors push a series of steel pins into the door frame for a lock more secure than any bank vault. Like the blast valves, the blast doors close automatically when a nuclear explosion creates a change in air pressure. With a lockdown system in place, NORAD was now equipped to seal itself off in the event of a nuclear war. The complex would stock enough water, fuel, and food, including 72,000 meals, to continue its mission for a full 30 days without any help from the outside. By late autumn 1965, all of NORAD's 15 buildings were assembled. The first 2 phases of construction were complete. It was now time to launch the final phase of the project, installing the early warning and surveillance system inside the command center of the new NORAD megastructure. Although the details of this intelligence were classified, NORAD made no secret of its primary mission: to track aircraft and missiles launched by known or suspected enemies. It would be up to those manning this megastructure to identify any airborne weapons entering North America's airspace. Phase 3 was a massive undertaking, and computer experts were in a constant race against advancing technology. But by the start of January 1966, the job was done. A Philco 200S computer was installed at NORAD's Command Operations Center, one of the fastest scientific supercomputers of its time in the world. The brains of NORAD were up and running at Cheyenne Mountain. On the 20th of April 1966, more than 6 years after construction began, the NORAD Command Center closed up its old headquarters in downtown Colorado Springs and opened for business inside Cheyenne Mountain. The entire project cost $142 million, the equivalent of more than $18 billion today. Hundreds of civilians work at NORAD alongside 600 enlisted personnel from the U.S. Army, Air Force, Navy, Marines, and Canadian military. From airmen to brigadier generals, NORAD is busy day and night, fully staffed in 8-hour shifts, 7 days a week, 24 hours a day. The cafeteria serves 4 meals every day, including one at midnight for those working the night shift. The underground work environment is unique. There are no windows at NORAD. In fact, the entire complex has a no-frills design that's been compared to the lower levels of a battleship.
There are people who find it very difficult to work in this environment. If you never see the sun, if you never feel the breeze, never see changes in temperature, it can be very difficult.
The government was very thorough in outfitting this megastructure.
NORAD was a statement to the world, in particular to the Soviet bloc, that the United States could be attacked, but they'd reply with a big stick.
For 20 years, NORAD scanned America's borders for airborne attacks from the Soviet superpower. Then, in November 1989, the US's greatest foe, and NORAD's primary reason for being, came tumbling down. The Soviet Union, the enemy that moved North America to build an indestructible fortress in the first place, collapsed. The Cold War officially came to an end.
Many people thought that NORAD, with the Cold War being over and there's being less of a potential possibility of an attack from the outside, that NORAD was obsolete.
Okay, stand by.
But as the world situation changed, so did the mission of NORAD. NORAD then expanded its mission of global surveillance to include missile threats from rogue nations like North Korea and Iran. Soldiers watched and warned of missile attacks from terrorists anywhere in the world. It was a mission that depended on complete overhauls.
It'll be like a Volkswagen. It always looked the same for years and years, but they kept fine-tuning the engine. They would change some things on the inside, etc. Well, that was what they said about the mountain. Well, the mountain will always look the same from the outside, but we'll be fine-tuning it and be changing it on the inside to adapt to current needs.
These needs require the brains of NORAD, its top-secret supercomputer, to be constantly upgraded and updated. Even though NORAD's surveillance systems were powerful enough to detect a 4-inch-long object in the Earth's orbit, the command post wasn't prepared for the tragedies of the 11th of September 2001.
On the morning of 9/11, we received intelligence that there might be an airliner specifically headed for Cheyenne Mountain. We closed the blast doors that day.
The attack on NORAD turned out to be a false alarm. But the terrorist attacks of 9/11 forced NORAD to update its role and mission once again. It was imperative that they revamped the center to prepare for, and more importantly, prevent, unpredictable acts of violence from future terrorism.
The threat has become much more asymmetrical, and by that I mean terrorism is out there now. The threat is no longer a bear, but it's a ball of snakes.
On the 4th of March 2005, NORAD officials unveiled their largest renovation since the mountain fortress first opened in 1966, their newly refurbished command center. It was rebuilt within the existing rock chamber carved out more than 4 decades earlier.
What you're about to see will show you we no longer need Hollywood to make our mission appear state-of-the-art and functional for its missions. Ladies and gentlemen, it's our pleasure to announce
we are now officially open for business.
This $15 million project took 17 months to build and doubled the command center's size. In today's post-9/11 world, NORAD is a state-of-the-art facility that now features the latest in detection, surveillance, and warning technology.
Any missile that's launched anywhere in the world will be detected by satellites and possibly by radar systems. And they're all tied into one global warning computer system that we're able to monitor here in the Missile Correlation Center.
Space Control Center Major Olden are coming up this outstanding First Space Control Squadron morning.
As a central command headquarters, NORAD's job is to assess the threat and coordinate the military force necessary to intercept or destroy the enemy. Officials now keep an even closer watch over the skies above their homeland. Every day, more than 10,000 aircraft are in the air over the U.S., and ever since the unforeseen airborne attacks of 9/11, any one of those planes could be a lethal weapon.
We are the agency of last resort, and we really don't want to be involved, and if we are, then it's gone too far already. That said, a quiet day here is a good day for us.
NORAD's mountain fortress was built to pass the ultimate test, to survive a nuclear catastrophe. A test it may never face because it's fulfilled its mission so well.
This is the most secure place you can be anywhere in the world.
It's a remarkable claim for a stronghold that's almost 40 years old. The engineers who designed it had a unique vision: to build a garrison where people could see out into every corner of the world, but where no one could see in. Hidden beneath 2,000 feet of solid granite, this military complex has faced many challenges over the years, including the rapid progress of computer technology, the unpredictable nature of an almost 2-mile-high mountain, and the persistent threat of random acts of terrorism. But NORAD has kept pace with cutting-edge advances in global warfare. This military megastructure keeps a constant watch over the safety of America and the world.